Welcome guys to our little summary of angles and segments in regards to circle. For the do now, we'll be naming the parts of a circle, and we just want to define what a circle is. A circle is a set of points in a plane that are equidistant from a given point. So a circle is a set of points in a plane that are all equidistant from a given point. Now we're going to use the circle above, and then we're going to name each segment in the circle. So the first portion we're going to identify is the center. The center is right there. Oh, it's a point from which all points of the circle are equidistant. So this is what tells me what a center is. Now in this case, our center will be point O. All right, next, we're going to identify the radius. Now the radius can come from the center to any point, but it's always from the center. It's a segment from the center of a circle to any point on the circle. All radii are congruent. So let's name some radii on this circle. We have OD, and we also have OC, and these are both radii. Next, we want to identify chords. A chord is a segment whose endpoints are on the circle. Now some chords are like FG, that there's a chord, AB is a chord, and we also have CD, the special chord. We call that chord our diameter. So let's name it. So it's FG. We're naming a segment, so we have to put the bar over it, AB, and then we have CD. So those are three chords on this circle. Next, we're going to find out what the diameter is. The diameter is a chord that contains the center of the circle. So this guy, CD, contains the center of the circle, and so that becomes our diameter. It's a special chord that goes through the center of the circle. Next, we're going to have Mr. Secant. So secant is a line that intersects a circle in two ways. Intersect means to cut, right? So let's see. This guy, E, F to G, is our secant because you notice it cuts the circle at F and also cuts it at G. So let's go ahead and identify our secant. Our secant is E, G. Notice where it intersects. Again, it intersects at F and G. Awesome, we're on a roll. Next, we want to identify our tangent. Now, tangent is not the same thing that we did in right triangles. A tangent in a circle is a line, ray, or segment that intersects a circle in exactly two ways. So let's look at our tangent. Our tangent could be E, H, I. Now, I made a mistake. It can't intersect in exactly 2 points. It had to intersect in exactly 1 point. So the point it intersects is at H. So our tangent is going to be E, I. All right? So we just want to recap that these special parts or segments on this circle is important for us to proceed in the lesson. So we know what the new things for us is that a diameter is a special chord. The secant intersects a circle in two ways or 2 points, and a tangent only touches a circle once. All right, so that's something that we learn. You should go ahead and pause this part before we go on to the next page so you could take your notes. All right. Now this segment I didn't add to your note sheet, so I want you to go ahead and add it to the back of your note sheet because I realized that there's some additional vocabulary that we needed to look at. The first one is the arc. Now the arc, we have been doing it in geometry, but the arc is the portion of the circumference. All right, and this is, so we have our circle and a very bad circle, but an arc would be just a small portion, So that could be an arc. Now you have minor arcs, and minor arcs would be small. Then you have major arcs, and those would be a bigger portion. Now arcs are measured in degrees. Alright, please don't mind. I'll just read what I said. It's a portion of a circumference. You have minor arcs. So minor arc would be this portion here. Then you have major arcs, which is a bigger portion. Minor arcs are small arcs. Major arcs are bigger. Arcs are measured in degrees. Alright, so you could go ahead and make note of that. Next, we have intercepted arc. An intercepted arc is the part of a circle that lies between two lines that intersect it. Now let's look at this guy. Alright, so the intercepted arc would be this arc right here. So this arc right here would be our intercepted arc because it lies between two lines that are intersecting the arc or cutting that portion of the arc. Alright? Next we have our circumference. The circumference, of course, we know that as the perimeter of a circle. Remember that circumference is calculated as 2 pi r, or circumference is equal to pi times the diameter, since the diameter is 2 times the radius. The area of a circle, just a reminder, is pi r squared, and that's all the portion of a circle that the circle will cover. Alright, so go ahead, take some time to write these notes down. I know it looks like scribbling, but the stylus I'm using is the best I can do in terms of writing. So listen to my voice and try to take notes. You could always go back. Alright, so I'll give you a minute, a few seconds to just make notes. Alright. Now let's get into some actual work portion. So say we want to find the area of a pizza slice, a sector. To find the area of a sector, now a sector is like taking a circle and just cutting out a fraction of it. So always remember this fraction. Now we need to go into some things before we get back to this. So what I will do is I'm going to move on to identify what a central angle is now, but we'll get into the formal definition. Now the central angle is actually the angle at the center, and in this case it is 60 degrees and the radius is 10. So right here we have 10. You're going to express your answer to the nearest tenth. Now the formula, as it says here, is A is equal to n over 360 times pi r squared. Now n over 360 will give us the fraction of that circle, and then multiplying it by pi r squared. Remember what pi r squared is, the area of a circle, so we're trying to find the area of that fraction of the circle, so it makes sense, right? Now let's go to identify what n is our central angle. It is 60, and then r is our radius, and in this question it says the radius was equal to 10. So we're going to simply put it into our formula right here, and then we work it out, and it says the nearest tenth. Awesome. Now let's go on to calculating the arc length. Now arc length is this little piece here. How long is this? Remember, this has to be measured in degrees because of the fact that we have this in degrees. Now there's a way for us to calculate it in radians, and we'll look at that when we come back to school. All right, so this question says, in a circle, the length of the arc of an arc is a portion of the circumference. Arc length over circumference is equal to arc measure over 360. Remember what an arc is measured in? It is measured in degrees. Remembering that the arc measures the measure of the central angle, a definition can be formed. Arc length is equal to central angle over 360 times the circumference. Let's look at this example here. In a circle O, the radius is 8, right here. And the measurement of the minor arc, remember, is the smaller piece, is 110 degrees. Find the length of minor arc AB to the nearest integer. So this is 110. You want to find out how much the arc length is. Alright, so its arc length is equal to central angle. Remember that the central angle is the same thing as the arc that it intercepts. And you'll learn that more in the next page. So it's equal to central angle over 360 times circumference. Arc length is equal to 180 over 360 times 2 pi r, which is 8. And then when we do all the calculations, it turns out to be 15. It says to the nearest integer, so we have to be very careful with that. Alright, so go ahead, allow this to marinate and see if it can absorb any questions. Please write down questions on the side so that when we come back, we can address what you don't understand. Take a minute, just do that, okay? Before we move on to the next page. Okay guys, welcome to a portion where you would need to have your rulers ready, and you should have your pencils ready. So you could pause the video right now so you could go get those materials, and then we can move on. Okay, so here we have two types of angles. We have our inscribed angle, then we have our central angles. Now let's first speak about what an inscribed angle is. So the definition, let's look at the definition right here. Definition of an inscribed angle. An inscribed angle formed by two chords, please fix that right there, to say, you should say chords, very good, in a circle which have a common endpoint. It intercepts a unique arc. So it's an angle formed by two chords in a circle. So let's go ahead and draw two chords on this guy right here. Alright, so we have one chord here, and I can't use a ruler, and another chord here. So this is A, this is B, and this is C. Now B, this horrible looking guy here, is the vertex where the two chords meet. So A, B is a chord, and BC is a chord. So these two guys happen to be our chords. That's a chord, and that's a chord. Alright, next. So we're going to look at this. Now AC is going to be my intercepted arc. We're writing an arc. We always put the 2 points and we put an arc over it. Let's get rid of that since we don't need that to stay right there. So the measurement of angle B, so this angle right here, is going to be a half of the measurement of AC. So that means that this guy right here, this angle, is going to be a half of this right here. I notice this angle is touching the circle. So B is our inscribed angle, and AC is our intercepted arc. Intercepted means something that is cut. Remember what we defined intercepted as before? You could go back to the previous page and you will see. The next one we're going to look at is when we have two, so there's an inscribed angle. Let's call it BC, and let's call this D. Then we have another one that also is supposed to be on. I messed up there. So let's call this A and D. Now, in this case, we have two inscribed angles that are intercepted by this same arc. See that? So this one goes this way, that's BAC, and then BDC. They're intercepted by the same arc. Now what you should know is that these angles are the same since they have to be a half of the same intercepted arc. So we could say that they are congruent. So two inscribed angles that are intersect the same arc are congruent. Alright, awesome. Next, we're going to look at a unique situation where we have our center here and then we have a triangle here. Now, this entire arc, it's a semicircle and adds up to 180. So that means that this angle, which is a half, so this angle is the inscribed angle, which is a half of this, is going to be equal to 90. It's going to be equal to 90. So an angle inscribed in a semicircle is a right angle, right here. Central angle is equal to 180. Our intercept is 180, so the inscribed angle is going to be half of that. All right. Next, let's look at this unique situation also. So be aware of these things, okay? Just make note of it. All right, say for instance, I have a quadrilateral. Now, this quadrilateral is not a perfect square, so please don't make that assumption. So we have angles 1, 2, 3, and 4. All right, so if they're opposite angles of a quadrilateral inscribed in a circle are supplementary. So that means that the measurement of angle 1 plus the measurement of angle 3, because these two guys are opposite, they're going to be equal to 180. Which one would be also be equal to 180? You go ahead, pause, and write it down. And then let's check. Okay, so a few seconds would be good. So the measurement of angle 4 plus the measurement of angle 2, so these two guys are also equal to 180. Now let's look at our central angle. Now a central angle is exactly what it is. It's an angle that forms when two radii meet at the center of a circle. So I'm gonna sketch a circle, and I hope it can be as perfect. It's the best I could do. And a central angle, we have our center, and then let's call this center A. The central angle are two radii that meet. So say this is M and N. So my central angle is right here. So the central angle is equal to the arc it intercepts. Alright, so it's meet at the radii. So this angle here is equal to whatever this is. Notice the difference. This one is at the center and inscribed angle. That one is on the circumference. So go ahead, absorb it in, and then let's move on. All right, the last in the angle series is the secant secant. All right, so let's look at this secant secant. So a secant, I'm going to draw one. Remember, secant cuts a circle in two parts. Secant and a secant. And so we have angle here. So let's call it GENIU. Only the S leaves to make you a genius. Let's make the S happen. Same thing like the tangent secant before. It's going to be the same thing. The angle is going to be the far arc minus the near arc divided by 2. So it's going to be equal to, so remember theta is equal to angle G and U. The far arc is going to be equal to GU. And then the narc or the near arc is going to be equal to EI. Alright, so that is going to be your near arc. So far arc is GU, the farthest from the angle. Near arc is EI. Notice we're not even worried about outside, guys. It's what's intercepted by the two secants. Alright. Now we're going to get into the relationship with circles and segments. Alright, so say we have intersecting chords. Alright, so let's look at intersecting chords. So say for instance I have one chord going this way. Let's call that chord M. Let's call this chord N. And say for instance I have another chord that intersects it here. Let's call this portion A. Let's call this part O. And where they meet, let's call that point. It's not the center. P. Alright, so we can say that chords MN intersect AO at P. Now what can we say about this? It's a formula so you could calculate. So MP times PN, so this small piece times this small piece is equal to this small piece AP times this small piece PO. Not too bad. So it's simply this piece times this piece is equal to this piece times this piece. Next, let's speak about the intersecting diameter with a chord. So we have our center. Our diameter goes through. And then we have an intersecting diameter and then we have a chord. So let's say that this is S, center O, this is Y, and then A, B. So in this case, the diameter would actually be, so our diameter SY is going to be the perpendicular bisector for AB. So what happens is that these two pieces are going to be cut equally. Therefore, AX, let's call this guy X, is congruent to BX. So this piece is congruent to this piece. Next, we're going to look at a chord and a tangent at the point of tangency. So we have a chord, then we have our tangent right there. Now, in this case, it's really nice. So whenever you have a chord, and our chord is going to be labeled AB, and then we're going to name this point P. So whenever you have a chord AB that meets a tangent line, a point of tangency, At the point of tangency, guess what happens? They're going to be perpendicular. It doesn't look perpendicular, but it always happens. So AB is going to be perpendicular to PB. All right. Next, say we have two secants. Let's just see how they behave. So say we have a secant here, then we have a secant there. Let's name our secant. So it's M O N A H. So in this case, it says that we have M O plus O N times M N is equal to H A plus A N times A N. Now, if you look at this, this represents the whole secant. And then, let's fix this guy right here. I made a mistake. This is supposed to be O N. So, this entire secant times the external piece is equal to the entire secant times the external piece. So there's a shortcut. We can say whole secant times external piece is equal to whole secant times external piece. It's wee. You get it? Alright. Take a minute, let it absorb, take your notes. Any questions, write it down. Alright, we're almost at the end of taking notes, and then what I'm going to do is speak about how we're going to look at the questions. Alright, so let's look at two tangents. So we have two tangents right here. So we have tangent right here, and we have a tangent right here. Use a different color for this one. It's going to look a little bit messy, but you get the idea. Alright, so what happened is we're going to end up with something looking like a hat, right? So say for instance we have our hat theorem, and it's literally called a hat theorem. Let's label. Let's call this X. Let's call this Y. Let's call this Z. Now, these two tangents are meeting at a common point Y. So if we have two tangents that meet at a common point, if two tangents from the same circle meet at a common point, then we can say XY is congruent to ZY. So XY is congruent to ZY, so we can say that these two guys are congruent to each other. Next, intersecting secant. So we're intersecting secant, and then we have a national tangent. Now what happens in this case? Let's call this G, E, and I for my geniuses. Alright, the tangent, remember what our tangent is? Only touches the circle once. So our tangent is IN. Square of that is equal to the whole times the external. Now, let's fix this. So, tangent squared, so it's IN squared is equal to, let's make the whole equal to, make it red. So the whole is equal to, secant is GE plus EN. Yes, agreed? And then the external piece, let's make that blue. The external piece in this case would be times EN. Alright, so it is Tangent squared. This guy squared is equal to this guy plus this guy. Adding them together times external piece. Alright. Next we're going to talk about non-parallel chords, which we did already. We're going to just look at it again. So that, hey, if I'm non-parallel and I'm like this, that means if I'm congruent chords, then I intercept congruent arcs. So that means that this piece is congruent to this piece. Alright? I am going to set up a quiz, and I would like you guys to take the quiz when you come. It's going to be on vocabulary. It's going to be on these formulas. So make sure as soon as you get these notes, you start making index cards, or you keep it handy on a formula sheet, because I'll be giving you a quiz when you come back. I will not tell you exactly what day. It's going to be a quiz on this content that we did here, and then we'll look into the model examples and some practice. Alright, so I'll see you then. Enjoy, and I hope this video was helpful. Please make your notes. If you're not clear on anything, please write down clarifying questions, and we can definitely have a conversation about that. Enjoy. Bye.